Hi, today we are going to learn how to predict an emotion based on a face image. So we will build a model based on a big dataset of faces that are being categorized to an emotions, and then we will take a test image, a fresh image, and try to predict what is the emotion of the face. For example, this one is a happy face and this one is a surprise face. So once again, you are most welcome to subscribe to my channels. More videos are going to be published soon. So first of all, let's start with downloading the dataset. So let's go to Kaggle, and inside the Kaggle website we are going to search for the faces dataset. So looks for FER 2013, and this is the dataset of the faces. You can see on the right side the categories. For example, this is an angry faces, and you can see there is a fear faces, happy faces, sad faces, and surprise faces. So basically we will download this dataset, and we will extract it and put it on a folder in our disk. So this would be the first face. Okay, let's download the images. I will spare from you the time. I already downloaded it and extracted on this folder, datasets, emotion faces. You can see there is a train folder with 7 categories, and there is a test folder. You can see it's a very small images. It's about 48 on 48, and it's also in gray images, black and white images. So let's, for example, investigate one of the images. Let's go to the settings, the details, and you can see it's 48 on 48. A very small images. So let's create a folder. We will call it emotions. All the code, of course, will be uploaded to my GitHub repository, so you can use it later. So let's create the folder. Let's move it to the right home folder, and now let's create the first Python program. We will call it step number 1, build the model. In this first program we will do some data discovery and build the model and train it as well. So here are the required Python libraries. We will use NumPy, and we will use TensorFlow and OpenCV, and we will use the OS library as well. So let's set up our train folder. And our test folder as well. Now let's read the names of the folders. It will be the list of our categories for the model. Let's sort it and print it. Let's run it. Okay, I have a syntax error in the TensorFlow, the word in. Okay, let's fix it and run it again. Okay, this is the name of the folders, and of course that will be the name of our categories. Let's create an array. This array would be for the images and for the labels, and one for the trained data and one for the test data. So let's start with loading all the images and the labels into the trained data. So we'll create a for loop, and the for loop will be inside of each of the category. That means in each of the categories we will load the list of the images, and each of the images will be inserted into our array. Let's print the name of the category and the name of the file that was loaded. And we will use the append function to insert the image into the xtrain. Of course, we have to load the image. We will insert into the ytrain the name of the label, but we will convert it to a number. That means that each of the folders will get a unique integer number between 0 and 7. In the end of the for loop, let's print the length of our array, our xtrain. So we will discover how many images were loaded and inserted inside this array. So you can see this is the number. More than 28,000 images. A lot of images for our data set. So let's, for example, print or maybe show the first image. So we will use the cv2 imShow function. So we are extracting into img1 the first image, and we will show it using the OpenCV library. So once again, let's run it. And you can see this is the image, a very small one. Okay, let's continue for the next step. We would like to print the ytrain. Basically, we would like to see values between 0 and 7. Let's run it again and see the result. I'm doing a fast forward for this process. So as you can see, we have the same number of labels, and for each of the images we have a value between 0 and 7. Okay, that's good. Let's continue for the next step. We will duplicate the process and we'll do it the same for the test folder. So basically, in the end of this process, we have 4 arrays, 2 for the train images and labels and 2 for the test images and labels. So let's replace the train with the test, and of course we have to replace the name of the arrays to xtest and ytest. Don't forget it. And let's print the xtest length to see how many test images we have loaded. Let's add the ytest as well, so we have to see the same number for the test images and the test labels. Let's run it again. as you can see, we have more than 7,000 test images and test labels. They are the same number. We are doing well. Let's continue to the next phase. We would like to convert this Python arrays to a number array. So we use the array function inside the NumPy library, and we will do it for each of these 4 arrays. Okay, next let's print the shape of the X-train. So we have to see, we would like to see 28,000 images by 48 and 48, and let's also print the shape of the first image, and we are expecting to see a list of numbers that are a shape 48 by 48, but so basically we have to see a list of numbers between 0 and 255, between black and white values. Okay, very good. So let's continue to the next phase. Now we have to do 2 tasks. The first one, we have to normalize the data. What does it mean, normalize the data? The values of each of the images should be between 0 and 1, and not between 0 and 255. The next one, we have to add another dimension, so the shape of each of the images should be 48 by 48 by 1. If it was a color images, it would be 48 by 48 by 3, like a RGB image, red, green, blue. But since we are using a black and white images, it should be 48 by 48 by 1. So let's start with the first task. It's an easy one. We have to divide all the values to 255, so it will be normalized between 0 and 1. And as for the reshaping, first we have to extract the number of images. This is the first dimension. So we will use the X-train with the zero position. That will be the first value of the shape. Then we will use the reshape, and we will send several arguments. The number of images. This is the 28,000, 48 by 48 by 1. So now, once again, let's print the shape of the X-train, and we are expecting to see a shape of the number of images by 48 by 48 by 1. Let's also print the first image, and of course we expecting to see values between 0 and 1 and not 0 and 255. Okay, this is the before the normalizer, and this is after. Very nice. And this is the shape after, and this is the shape before. As you can see, we are done. Next, we are going to do the same process for the test images. We will copy the same commands as for the trained data. So let's get the amount of test images, which is the first dimension on the X test, shape of 0. Then we will shape it, and let's print the shape again. Let's run it. As you can see, we have more than 7,000 images. And now the next process is converting the labels to categorical labels. As I mentioned earlier, as for now, each of the label has an integer value between 0 and 6. We have 7 categories, so it's 0 to 6. And now we have to convert each of the integer values to categorical value. That means, for example, if the first label is 0, then we will have 1, 0, 0, 0, 0. We will print the outcome, then it will be more understood. Okay, so now after we convert the labels to categorical, let's print our labels. Let's do some printing. For example, let's print the all labels of the terrain. Let's print once again the shape of the labels, and let's print the first label. Let's run it again. Let's do some fast forward to the end. Okay, as you can see, the values are now 1, 0, 0, 0. This is, for example, the integer 0, and you can see we have more than 28,000, and I also print the first label of the first image. Right, so now we are ready to create our convolutional neural network model. Let's build our model. First, let's define our input shape. Let's extract it from our train images. Basically, it would be 48 by 48. Next, let's import some Keras objects and functions. We need, of course, the sequential object. Our CNN model is a sequential model. We will also import several layers. We will use the dense layer, the conv2D layer, max pooling, flatten layer, and a dropout. We will use the optimizer Adam. If you're not familiar with this process, you can catch up some of my previous tutorials. We will also use an early stopping. That means that if, for example, our model will not improve with several iterations, we will stop the training. And we will use the matplotlib to demonstrate a chart with the training result. Let's define our model. It will be a sequential. Then we will add the first layer. The first layer will be a convolutional 2D layer. The input shape would be our input shape variable, which is 48 by 48. Then we will define 64 filters for the first layer and a kernel size of 3 by 3. Activation ReLU, and let's continue for the next layer. The next layer will be another convolutional layer with the same figures. Then we will add a max pooling layer with a pool size of 2 by 2. a very straightforward process, and the stride will be also 2 by 2. That means that the movement along the convolutional layer will be in 2 positions. Then we'll create another convolutional layer, a bigger one, that will have 128 filters. A second convolutional layer and the max pooling layer. We will duplicate it and raise the number to 256. And once again, we are going to duplicate it. We will have three layers based on 256 and a 512 filter convolution layers, 3 of them, and then another max pooling, and then another one of the 512. Then we will flatten the result, and let's add a dense layer of more than 4,000 neurons. The next layer will be a dropout layer. That means that we are going to drop half of the activated layers. So activated neurons. Another dense layer, and at last, this is our dense layer of 7 categories, and the activation would be softmax, which is the relevant one for categorical CNN. Let's print the summary of our model and see the result. Okay, we can see all the layers. We can see the input shape. We are ready to continue to the next phase. Now let's compile our model. We will have to define the optimizer, which is Adam. We will add a learning rate, a specific learning rate, a very small one. We will define the loss as categorical. And the metrics will be accuracy. Next, let's define the batch number. That means how many images would be trained in every batch. Let's define it at 32 and 30 epochs. If you are lacking memory, you can reduce the size of the batch to 16 and try it again. Then we'll define the steps of epochs. Basically, it's the number of images divided the batch number, and the same for the validation steps for the train images. Now we'll define the early stopping. In the early stopping, we have to define which variable or which value we are going to monitor. So in our case, it will be the validation accuracy, and the patience will be 5. That means that if the validation accuracy was not improved over 5 times, 5 iterations, then the training process will be stopped. So now finally we are in the training process. We will use the fit function, of course, as some crucial arguments for the fit process. So we will send the X train, which are the images, the Y train, which are the categorical labels, the batch size, which is 32, the epochs, as we define it as 30, the verbose will be 1, validation data will be our X test and the Y test, of course. And that's it. We have another value, shuffle through. Yes, that is also important, since we loaded the data without any shuffling. And now let's add the early stopping to the Feit process as well. What's next? Now we will add the charts that display the result of the training. We will compare the accuracy to the validation accuracy, and the same for the loss. So this is a typical coding how to draw a chart of the progress of the training. Of course, the chart will be displayed after the training. So let's run this code. You can type it during the session, or of course I will leave the code in my GitHub. We are creating the plot, so we will display the epochs and the accuracy as a red line, and the validation accuracy as a blue line. I'll also update the labels that will be displayed in the chart. So the X label will be the epochs, and the Y label on the left side will be the accuracy. Also, we will add a title for the chart. This would be the training and the validation accuracy. The legend will be displayed in the lower right position. And the last command is show the chart. And now we will do the same process for the loss. The last phase after displaying the charts, we will save the model. We will store it on a temporary folder, and we'll call it emotion.h5. And we'll use the model.save function. I can see now that I have a mistake. The epochs is not an integer value. We have to replace it or update it. In the chart, it should be a value between 0 and the number of epochs, so we will define a range of the length of the accuracy. That will be a list between a 0 and the total of epochs. So now we can run the training. As you can see, I run it on a fast forward since it took about 2 hours. So we will see several epochs, but we will not have to wait to the end of all the training. I will run it through the last phase. So as you can see, this is about 18 epochs out of 30, and this is the result of our model. It's not a very good one, but it's good enough to test the results and to detect emotion on images. So we can see this is the model file. It was stored on the temporary folder, and let's for example take this image. You can see it's a color image. May I remind you that we have trained a black and white image. So these two images were downloaded from Google, and now let's write some code to test these two images. So first of all, we will import some Python libraries. Let's import TensorFlow, import OS, import the image to array and the load image from Keras utils, import NumPy, and import OpenCV. Now let's load our model, our saved model. Let's copy the name of the path to the model. We will use the load function from Keras. It's called load model. And let's print the model summary just to double check that the load finished successfully. Okay, next. We need the categories of our model, so let's load it from our train path. This is our train path. We will use the os.listdir and send the train path as argument. I can see that I forgot the import OS, so let's add it. Let's sort the result and print it. So basically we will have our 7 categories on a list. Let's also print the length of the categories, and the value should be 7. Let's run it. Cool. We have the 7 categories, and we can continue for the next phase. The next phase is a little bit tricky. Since we have an image with a lot of information and background, we need to capture only the face out of the image. So in order to do that, we need to use an OpenCV function that is based on an hard cascade file. So you can download the file from my GitHub. You can see where I store it. This is my GitHub. You can go to a repository named face detection, and here you can find this file, hard cascade front face default. So you should download this XML file. You can copy the file wherever you like. I will put it on a temporary folder. Now let's go back to our code. We will need to define the classifier. We will do it inside the function that will find the face, capture the face out of an image. And first of all, let's use OpenCV to read the image, our original image. Then we will convert it to grayscale. Once again, using an OpenCV function. Our model is based on grayscale, so we have to convert it from RGB to grayscale. Then we will create our face detector. So we will use a cascade classifier, and we will send as an argument the file that I mentioned earlier. And now we will run the detect function. It's called detect multi-scale function out of this classifier, and this function will return the faces. These faces results, that means that in any image can be more than one face. In our example image there is only one, but you can also do it with the image with several faces. Then we are running loop inside this faces variable and get the coordinates x, y, width and height of each of the faces. So first of all we will draw a rectangle around the detected face. It will be a blue rectangle. And let's test this code so far. So we will define the path for our image. Let's take this surprised image, and we will send it to our new function. As for now, our function does not return anything. We will deal with it later, but as for now, just to see that we don't have any errors. Maybe we should add show in the image. So let's use the imShow function from OpenCV, and we will display the original images, the original image, just to figure out that it works fine. Okay, so this is our original image with the blue rectangle. Now let's replace it to our gray image. Let's run it again. Okay, we forgot to fix the rectangle. The rectangle should be displayed on our gray image. Cool, that's nice. So basically we would like to extract out of the image only the face. We don't need the hair, we don't need the background, only the face. So we will define the region of interest. I call it ROI gray, and we are capturing out of the gray image, we are capturing only the face area. So now let's deal with returning the outcome, this ROI gray. Let's return it, and let's show the result out of the function. Let's run it again. Cool. So now we are ready to prepare the image for our model. So let's define another function. We will call it prepare image for model. We will send our face image. Basically it will be our ROI gray. First we have to resize it to 48 by 48, since our model was trained with 48 by 48. We will use the CV2 resize to resize our image. Next, we have to extend our image to create as a batch of images. So we will use the expand teams. That means that our IMG result will be based off a shape of a 1 and then 48 by 48. Then we will divide it to 255 to normalize it between 0 and 1, and then we are ready to predict our image. Okay, let's extract the results from our prediction. No, sorry, let's code the predict process. The outcome of the prediction will be in the result array. We will use the argmax function, which gets the position of the higher predicted value. It will be understood in a few seconds. We will print this higher value which is stored in the answers variable. So let's run the prediction. As you can see, we got the value 6. What does it mean, the value 6? Let's copy this value next to our seven categories. As you can see, 0 is angry, 1 is disgust, 3 is fear, 4 is happy, and the last one, surprise, is the 6th value. That means that it was predicted correctly. Now let's take the text out of our categories, so it will be more convenient to see the outcome. So our categories array has the list of categories. Let's create a text file that will have the final predicted text. And let's show this predicted text along with our image. So once again, let's load our original image. Let's choose a font. This is a straightforward process on the OpenCV. And let's put the text on the image. Let's choose a position, the thickness of the font, the color of the font, the color of the text, and let's show the image. Let's run it. As you can see, we have a surprised image with the text surprise. Cool. Let's try it with another image. The next image is in a different dimension, different colors. So we are running the same prediction process. Let's run it again. Happy. Thank you very much. Hope you enjoyed this tutorial. Bye bye.